Okay, for today, this is technically 14.2, and it's called sinusoidals. Do you remember me telling you that everything boils down to sine? Because tangent, even though it looks totally different than sine, is sine over cosine. And cosine is really just a shift of sine, so like it all comes down to sine. So everybody, why don't you start by just graphing a classic sine for me, and tell me what the 7 important spots are. 1 of them, 2 of them, 3, 4, 5, 6, 7 spots. Those 7 spots, this one's the one that you probably don't really need to label. Those are the classic 7 positions of sine that you need to know. Because we're going to, of course, not ask you to graph, just graph y equals sine. It won't be that easy. But you'll start with that. I'll pause for a second while you do that. Okay, so here's the classic 1, negative 1, 2 pi, pi, pi over 2, and 3 pi over 2. Those are the main ones you need to know. Raise your hand if you had those all dialed in. Okay, good. Then, if I asked you to change this to y equals 3 sine of 2 theta minus 1, I'd like you to go through and make all the changes necessary to do that. Actually, I'm going to make your life a little easier. We're going to subtract 3 at the end instead of subtracting 1 because it'll make it move nicer, more nicely. I'll pause for a moment while you give that one a try. Okay, so the 3 up front is fairly simple. That changes this to a 3 and this to a 3. And I want you to note for a moment, the distance right there, that is 3 also, and that is where you should find the amplitude. Don't practice finding the amplitude right there, because what if the graph is moved, like this one will be? Say it's moved down here. Now you got to say, whoa, the amplitude's 0? No, the amplitude is from the central line, the line that runs down the middle of this thing, up to the first peak. That would be its amplitude. Okay, so we'll move it in a moment. Next thing is, this 2 here, you hopefully remembered that that's not doubling everything, it's cutting everything in half. How many of you remembered to put a half at all of these spots here? Okay, good. And that makes this new number pi over 4. This one's pi over 2, that's pretty easy to see. This one's 3 pi over 4, and this one's pi. And if you wanted to count it up in a nice logical way, it'd be 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Does that make sense to you guys? Okay, good. Now, the last step is that minus 3. So I got to move this whole thing where? Down 3. How far is down 3? Well, if I just focus on the end of this thing, like where it's at 0, 0 right now, and move it down 3, everything else will follow, right? There. Cool. Now, I did not make this perfect because my graph was not all straight. This was like rising a little bit as I was moving to the right. That's why this isn't touching right now. It should be touching right there, but it wasn't perfectly symmetrical. So, all right. There is a typical normal sine problem from not I haven't even looked at the test, but that's the type of stuff we test you on for sine, cosine. Now then I moved you to the ones that ride on their back. Do you remember those? As in, all I'd have to do right now is change this to, from sine to its sister function, which is what? Cosecant. CSC. Not cosine, cosecant, CSC. And that would mean now I have to make some things different about it. Well, first of all, let's go back to where it was in the first place. That was where sine was in the first place, right? And the asymptotes for this guy are going to run right, I'll use some pink ones here, right there, and there, and there, because that's where sine equals 0. Okay? So even if I shift it down, those asymptotes won't change. Oop, undo that. Can you get the door for us, please? Thank you. There we go. I'll move this down. My asymptotes still stay in the same spot, and it won't be as easy to see why because I moved it down. But then it's supposed to ride on the sister function's back, so you go like this and this. And this is a weird one because we've already done all the shifts and stuff. All right, let's give you another one that's similar to that. Let's say I asked you to graph 2 secant of 4 theta. We won't make it do anything more like move up or down or whatever. We'll just try that one. Again, by asking you to graph secant, I know you're really not going to graph secant. You're going to start by graphing cosine. All right, I'm going to pause for a second while you give that one a try. Okay, let's see how this went for you. First off, you got to start by graphing, listen please, cosine. You're correct, you don't have to. But what I'm afraid of is people will put the asymptotes in the wrong spot if they don't graph cosine first. Okay, so here's cosine. Cosine starts up high and then goes down and then hits the bottom and then comes back up again and you're up to the top. Okay, then this is 2 pi. And this is pi, and this is pi over 2, and this is 3 pi over 2. And now I know to put the asymptotes right here and here. All right, then it rides on the back of the sister function, so it goes like this, and like that, and like that. That looks a little weird, but it's right. Now, if you want to complete these little loops, that's okay, but now do you realize you're going past 1 full period if you do that? If you want to complete this loop over here, you've now got 2 upward loops and 1 lower loop, and that means you've got 1.5 periods of this thing. See what I'm saying? Yes. Well, if you graphed all of that when they ask you to graph 1 period of cosecant, yeah, absolutely, because you've graphed 1.5 periods of cosecant. So my suggestion is to just leave it like that, and then you've graphed 1 period. Now, would you rather get rid of this and graph that? That's okay. You can do that. Then you just need to put the other asymptote that runs down here in and know where it would be. And I would count it up 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. That'd be at 5 pi over 2. It's another option. Yes?
Okay. So if you had a question on the test that had a picture of a cosine graph, right?
Okay, yeah.
And you said sine minus 3 pi over 2, technically wouldn't that be right?
Okay, so are you just asking about how sine and cosine are just a shift of each other?
Well, yeah.
Okay, so here's sine, and here's cosine, and it ends in the same spot here. And I'm not going to do this perfectly, but now you were asking, is sine and cosine just a shift of, what did you say it was again?
3 pi over.
All right, so if you want to shift this to the right, 3 pi over 2, let's see if they actually line up.
I kept you both ways.
Okay, so which one? I'm gonna choose to move this one to the right, 3 pi over 2. Well, how do I know where 3 pi over 2 is? It's that spot right there. So then I shift this to the right, 3 pi over 2, and look at that, you were right. It's a shift to the right of 3 pi over 2. Okay? Or, couldn't I have shifted it to the left? Yeah. How far to the left would I have needed to shift it? It's just this distance right here, right? So how far is that distance? It's pi over 2. And then look at that. It would also line up. They're not matching perfectly because I didn't draw it perfectly, but all right. Okay, so yes, there is that relationship. It's just a shift. Then, here's the trickier kind. What if they throw in 3 sine of 4 theta minus pi plus 1? That's got all the elements. That's got an amplitude of 3. That's got a b term of 4, a shift of not right pi. It seems like it's shifted to the right pi, but it's not. You got to factor it first. And then it's also been shifted up 1. All right. And I'm glad you remembered. If you can factor it, you should. Go ahead and factor this thing and rewrite it. And then sketch it. This part right here is the part that can be factored, yes. Take a 4 out. That's right. Okay, it should be easy in a class at this level to factor out that 4, you get theta, and then this is minus pi over 4. Okay. If you're questioning why that would be, if you multiply it back out, I think you'll see that it actually will equal negative pi like it should. Okay, then your sine, normal. 1 and negative 1. Always start with that. Then, it's not normal, so I make this a 3. Then, that 4 tells me to renumber everything. Do I multiply everything by 4? No. Multiply everything by 1/4. So I'm dividing this by 4, timesing this by 1/4, dividing by 4, timesing by 1/4. And this is pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8, also known as pi over 2. And now, how far should I shift it? To the right, I'm supposed to go pi over 4. Ooh, I can see that distance. It's right here, and that actually means it's this distance. Right, I'll do it in pink here. This distance is how far I should move it. To the right. So, I'm going to grab my function and move them over that far. I just moved all my numbers over. Great. Okay, so instead I will draw a new one on top of it in black, and then move it. So there, I'm going to move it over that far. Cool. Yeah, it had to be a pain, but I'm showing you that I move it over that far. And then one last thing, what's that little plus 1 going to do? Yes, sir. Up 1. And how far is 1? Well, this says how far 3 is, so I'm going to divide it into 3 spots and then move it up about that far. There. Should I leave the original in there, I think is the essence of your question, and the answer is no, I should not leave the original in there. The original was a good place to start, and now at the end of the answer, this is not there. That red one's not there, so I'll pull out my surgical eraser here, small, and...
Do we have to show the test?
Do we have to show any work for this test? Yes, but...
No,
but
like you could just make a graph and just fill out.
If you draw a perfect graph and label it on its x and the y-axis perfectly, then you're correct. I don't have to see what you started with. But what's worse is if you leave the original stuff in there, like you leave your work in there, it's actually worse this time, because if you leave the sine graph in when you were actually supposed to graph cosecant, well, and you're telling me that you think cosecant has this wave in it, and it doesn't. It has the loops. Yes? You need to add more variables. Oh, I think maybe what you mean by variables is, do you have to number it further? Yes, you do. If we ask you to shift this thing over, we would ask that every spot that it is over have a label. So I would need to know how to count. 1/8, 2/8, 3/8, 4/8. That makes the next logical spot. All right, 5/8, 5/8 pi, and 6/8 pi, which really should be reduced, but it'll keep the theme going nicely. So yeah, you do need to be able to know what those spots are. Yes? No, because then all of a sudden weird things happen like this. If you had to move it down 1, and all of a sudden you're saying that that spot is 1, no. If you're going to have to do it vertically, you have to actually erase your graph and move it. Yes?
Okay, so my question is, if we're shifting over right, do you not want us, instead of like keeping it in between 2 pi, do you want us to like actually like move it over and go past 2 pi?
All right, now, so what I did was actually move it over and go past 2 pi. Now, there was another option instead of labeling this stuff out here.
Right, you could just draw it back.
I could draw it backwards, you are correct. And go, okay, so this thing is heading down, and then it's coming back up, and yeah, I could have just done that and not had to extend it out any further. That absolutely would work.
Okay, so we can do that.
Yes, you can do that.
Okay, and then, are we going to get into, like, reflection?
Yes, but The main kind of reflections you have to worry about are if I throw a negative on the outside, the up-down kind of flip. Because the left-right kind of flips can be pretty vicious to envision, although if you think about them, if I know this group, sine of negative x is equal to negative sine of x, this reminds me that a flip on the inside or the outside would act the same way on sine. And also, are you expected to know this? Yeah, you are. What does that tell you about an inside flip on cosine? It doesn't do anything. It looks exactly like normal cosine. Okay, and one more thing. Tangent. That says that an inside flip on tangent is exactly the same as a up-down flip on tangent. A horizontal and a vertical reflection will look exactly the same. Yes?
So, if for example, like the sine of you're factoring that, you take out the negative?
Okay, hold on. Sine of it. No, you can't just factor that and take out the negative. That's sort of like saying sine of negative 30. Get what I'm saying? You can't factor that negative out to the front. That does not work. Otherwise, if it did, cosine would have a negative here too, wouldn't it? Yeah, you can't do that. It won't work. Can't factor out a negative from inside where the angle is to outside in front of the function. Two different things. So this cannot move out there. That doesn't work. Okay? All right. And really the best example of why it doesn't is that for cosine, because it doesn't have a negative on the outside. All right. You guys asked a lot of questions, which are good questions, but we need to move on to the new stuff for today, which is instead of I tell you an equation and you tell me the graph, what if I tell you the graph and you tell me the equation?
Because now we don't have to make it.
That's true. Can you tell that that's cosine?
Yeah.
It's maybe ugly cosine, but it's cosine. Or it could be sine but shifted. That's a good point. But how do you know? So I recommend for day one of this that since this is called sinusoidals and they all can boil down to sine, that you just start with sine. Okay? Now, you can also, which once we get into some real world problems later, it's actually easier to start with cosine. But for right now, just make them all sine. It'll make your life easier. Okay? So if that starts as sine of x, and I know it could have been a cosine, but anyone can be represented by sine. Any wave can be made into a sine function. So what is it? Well, I'd have to tell you some numbers, right? Because if I just say this is the classic positions, 1, negative 1, that's at 2 pi, do you get, I don't have to do anything, it is just sine. Okay, but if I change this to 4 and negative 4, and that's 2 pi over 3, oh, then it's a little more complicated. That's more like it. Now tell me the equation for that one. I'm going to pause while you give that one a try. All right, that was a good question. Somebody said, well, isn't that just a cosine graph? Couldn't we use this as cosine? Yes, you could use this as cosine. But if you're going to make it as sine, it's going to have to be shifted. So you do bring up a good point. I did not graph sine right off the bat. I graphed cosine. All right, so this does involve a shift. It involves a stretch. And it involves both a horizontal and a vertical stretch. So this is a tough one. I'll pause for a second while you give this one a try. Okay. So I did not throw you a nice, soft, easy first one, but at least do you get that it appears that it's just been stretched with a vertical factor of 4? Raise your hand if you had that part right. Good. Then, would you agree that our period here is not the normal 2 pi? Now, I've got an equation for that I recommend you use. Period is 2 pi over b. I told you that a few times, and a lot of you guys got just so used to going, well, you just flip the number over. Well, it doesn't always work so nice. But if you have this equation in your little set of tools, it helps a lot right now because the period has been given to you. I didn't tell you the b, but I told you the period, didn't I? What did I tell you the period was? 2 pi over 3. So I erase period and I put in 2 pi over 3. And do you get now I can solve for b? And apparently B must be, can you see it? 3. All right. So B must be 3. See, if I put a 3 there, they'll be equal, right? Okay, so bottom line, B is 3. Now, it would be even more disgusting if I had made this into 4 pi over 3, and then it would be even more complicated to figure out exactly what to do. You would put in instead, though, if you use my little equation method, period is 2 pi over B, period is 4 pi over 3, and then I could solve this. It'd take a little more multiplying and stuff. Cross multiply and solve. I'll show it to you quick. It'd be 4 pi B equals 6 pi, and then I would divide both sides by 4 pi, and it would be, cancel the pi's. Instead of 6/4, I would say 3 over 2. All right. But I didn't make it that nasty. I made it medium nasty, and B was 3, and so therefore there's a 3 there. Raise your hand if you had that part right. Okay, good. Now the last thing is the shift. Remember, this is not actually sine. This one's cosine. So, couple options. What's the simpler of the two? Isn't sine when you've got cosine, couldn't that have been sine except if you shift it to the right a little bit? Or to the left? Okay. No, you don't want to do plus and minus. No, you want to do one or the other. Okay. So let's say if I take sine and I shift my sine, here's the original sine. Nope, I'm wrong. It's terrible. There we go. There's original sine. Okay, and I just take my original sine and shift him to the left a little bit, I have it, right? If I take the green one, which is sine, and I shift it to the left a little bit, how far is a little bit? Pi over 2 is correct. So, that was a nasty one because of that whole pi over 2 shift. But at least could you have gotten the 4 and the 3? Raise your hand if you could have gotten a 4 and the 3. Okay, good. So now let's do another one, except I'll actually start with sine this time, but I am going to add a little nasty twist at the end. Here's sine, and instead of 2 pi, and instead of like 2 pi over 3, it's going to be 5 pi over 3 is its period. And this one has been shifted up a little bit because it's at 5 here, and 3 here. I'm going to pause for a second, see if we can figure this one out. Okay, one critical piece that I want to help you with to help you finish this. I know a lot of you are not getting it. I want to give you this little tip. Do you get that this wave has actually been shifted up a little bit, and this line of symmetry down the middle is actually up there? And this is at 1, which has how much distance to that then? 4. And this goes down how far? 4. And so can you tell its amplitude from that then? The amplitude is on the board now, and the shift is on the board now. So that little dotted line here running down the middle, its line of symmetry that runs through the middle of it, that's critical to know. Yes, sir?
But isn't the middle 4 instead of 1?
The middle? The distance here is 4, and the distance here is also 4. Did that help?
But it's a positive.
No, it's a positive 3. It's 1 and 1.
1 and 1.
Because the lower
Yeah, it's shifted up 4.
And so the middle is like the.
The 3 on the
Yeah,
bottom
it's
is
shifted
higher.
up 4.
No, it's
So, like,
switched by 4. That we got
put negative 3 at the bottom.
Oh, they are supposed to be negative, yes. I thought that I... Oh, okay, serious? Okay. I didn't even think about how that was negative. It has to be negative. All right, sorry about that. That is a negative 3. You're right. But then the x-axis or this line The x-axis could not have been where it, if it wasn't, if that was a positive 3, then the x-axis would have to be down there, but it's not. So all I screwed up on was that negative right there. I apologize. I will pause for again while you figure it out for reals. Okay, we got to get this one over with. I kind of gave you the punchline when I said this dotted line here was important because that told you the 4 amplitude, and that also told you that this is up 1. The line of symmetry is up 1 from where it used to be, so there's a plus 1 down there. And then the last thing is, what's the stretch here? We did not have a normal period. We had the period equals 2 pi over b, and I don't know b, but I know the period. I replace the word period with 5 pi over 3, and then I do some cross multiplying. I get 5 pi b equals 6 pi. Divide both sides by 5 pi, and b is 6/5. How many of you figured that out? Lots of you. Impressive. Okay. So, one more. This one's a fairly tame one. Let's see here. I'll make a wave. There's this normal sine wave, but it's obviously been shifted up quite a bit. How far? That's for you to figure out. If this is at 2, and this is at 8, then, oh, and I'll do one more thing. We'll just keep your life a little better by making it have a normal period of 2 pi. Then, what would the equation for that have to be?
6 equals sine. It'd be at 5. And then
I'm going to pause for a moment. So those mournful souls who are just staring at the board, let me help a little bit. I told you this line would be really important to figure out, right? And it shouldn't be tilted like that, but it is. So anyway, there's no slant asymptote going on here or anything. This has just been shifted up. Once you know where that line is, life's a lot better. Who's got where that line is? What is it? 5 is correct, because just logically, if that's 5, this would be a difference of 3, and that'd be a difference of 3, and that means you know the amplitude, and you know all kinds of things now. Now, if you're like, how did you get that 5? You could just average 8 and 2.
that's 5.
That's a cheat way to do it. No, it's a math way to do it. The average is what's exactly between two things. It's the average of those two things. All right, so then y equals sine x. That'd be right if I hadn't made any changes, but I did. I moved it up 5. Raise your hand if you had the plus 5 on the right. Good. Then in front of it, I don't have a 5. And another common mistake I have is people will put in 6 because they say it goes 6 between here and here, but that means the amplitude's a 3. It's this distance. That's the amplitude. Okay? And then last but not least, has it been stretched or moved to the right on the inside? No, because it had a period of 2 pi. Now it's got a period of 2 pi over 5. Change your answer accordingly. If the period is now 2 pi over 5, what you gonna do? All right. He's saying 1 over 5 goes in here. How many of you guys agree with him? Ooh. Maybe you didn't mean that. What should go in here? Oh, a 5 should go in there. Now how many of you agree with him? All right, good. Good. So, that's from me giving you a graph, but I don't even need to give you a whole graph. All I really needed to give you was how high it was and how low it was and exactly what the coordinates of that point are. I'm going to go back to when it was a little simpler and this was 2 pi. Okay? Because that'll be a lot easier to tell what these points were. Would you agree that this spot right here, that spot right there, is at how far over?
That would be 3 pi over 2.
You are correct. And how far up?
That would be
2. And this spot right here, right there, would be
2 pi
pi over 2, and 8. Do you get from those 2 points, I could glean all the information I need to write this equation? Just think about it. This 3 right here, how would we have got it? Well, first of all, we would have thought the 8 and the 2 average to a 5, and so this middle line is x equals 5, and we could have got that from just the 8 and the 2, couldn't we?
Yes.
And once we knew that line was at 5, we could say, oh, from 5 to 8 is an increase of 3, and so, boom, I know that my amplitude is 3. The next thing is this 5 becomes the shift at the end. The dotted line, the new line of symmetry that runs right down the middle, that becomes this. And then that only leaves me with one thing, and that's to figure out the period, and that's the hardest part, so pay attention. How do I get this period from just pi over 2 and 3 pi over 2? Well, one thing, do you get this is not a full period when I go that far? It's only half of a period. So if I figure out how far I went and then I double it, then I'll know what the period is. So how far is it from pi over 2 to 3 pi over 2? Well, you subtract. You take the bigger number minus the smaller number. And that makes 3 pi over 2 minus 1 pi over 2 is 2 pi over 2, also known as pi. This distance here is pi. It's pi from here to here. If it takes from the high spot to the low spot, it takes pi to get there. Then to finish it off, we'd have to go another pi, right? So our period on this one is 2 pi. We got that by taking this number and this number, which was 3 pi over 2, and subtracting them and then doubling the result. So let's see if you can handle this. Here's a high spot. And it's going to be at 10 for its height, comma, let's say it's over pi. Nope, I should say pi comma 10, sorry. And then there's a low spot over here. And it's at 3 pi, that's a strange number, comma 2. From these 2 points, you can write me an equation. And what did I say was the most important part? The line of symmetry that runs down the middle, because that helps you start seeing a wave. Okay? If it was just sine, it'd be so simple. Okay? But we tweaked it, obviously, a fair amount. Because if I was going to complete this little wave, it would kind of look like this. There. Now I got a sine wave. And then where's the x and the y-axis? Well, the y-axis is over here somewhere. I don't even know exactly where. The x-axis, well, at least this much, this is up 2, right? 2 up off of the x-axis. So the x-axis must run along like that somehow. So my whole graph has been shifted up. All right. So then, would you agree that this number is the amplitude? And so if I average my 2 and my 10, add them together, you get 12. Divide by 2, I get 6. Raise your hand if you had 6 for that line that runs down the middle. Good. Then, do you agree the whole thing's been moved up 6? All right. We're into that homework time. I'll give you that in just a second here. All right. Then, would you agree that it has been, or has an amplitude that goes from 6 to 10, which is 4. So there's a 4 right there. Raise your hand if you did that part right. Good. And then lastly, to figure out this part of whether it's been stretched and moved and all that stuff, there actually might be a shift in here that I didn't even think about, but here's what I would have wanted you to do. Take that and subtract them. 3 pi minus pi makes what? 2 pi. Did it complete a full cycle when it got that far? No. So 2 pi was not its period. You got to double that and say 4 pi is its period. If its period is supposed to be 2 pi over b, and its period actually is 4 pi, now I can solve that little equation, and it will be 1/2. Now, I am aware that there's also a shift in here that I didn't factor in, and I'm going to just ignore that and say that would make it much more complicated than I intended it. So, all right. So your homework for tonight is to do 2 easy graphing questions, 1 medium graphing question, which is this guy. It'll be written on the backside of a worksheet. And lastly, one of those problems where I give you a max and a min, and you have to figure out what the equation looks like with all of its A's and B's and C's and D's. All right, so here is the first part. It's a green worksheet. I am going to be making a copy of this and posting it for anybody who's absent today so that they can get this exact sheet. And I'm going to have you write the problems on the back side that I have on the board here, so I'll need to pause for a moment. So on the back side of that green worksheet, we have 2 questions that I'm going to have you write in. Y equals 3 cosecant of 2 theta. You should be able to graph that by now. It's just got 2 simple little stretch type adjustments to it. And cosecant will force you to graph its sister function first, if you're going to probably put the asymptotes in the right spot. So this sort of makes you do a couple things. That's why I said it was a medium difficult kind. And then the last thing I want you to do is one of these problems where I'm going to give you the min and the max. The min, the low spot, is at 5 pi over 6, comma 8. And the max, the high spot, is at pi over 6, comma 13. Then you'll be able to write me a sinusoidal equation for that. And it'll look something like, this is not the answer, 14 sine of 2 pi minus 1, or that kind of thing. All right? Remember, my advice was finding that line that runs down the middle is so powerful. Once you figure out that line, you'll know the amplitude and how much it's been shifted up so quickly. Just find that line that runs down the middle of it. That line of symmetry helps a ton. Okay, that's all I got for the advice and the homework for today.